Okay, so first we have to get marginal densities here. Let's do those. So we know that x is equal to 0 is this first row. So we add up that first row. So 0.11 plus 0.06 plus 0.06. So that's 0.23. And then x is equal to 1 is the second row, so 0.04, 0.25, 0.07, they add up to 0.36. And x is equal to 2 is the third row, 0.19, and then 0.41. Similarly, y is equal to 0 is the first column, so 0.15, 0.23. Y is equal to 1 is the second column, 0.42. And then we add up the third column for y is equal to 2, so 0.13 and 0.35. Next, we have to give the probability distribution of x given y is equal to 2. So x given y is equal to 2. So let's write it out like we do. So probability, we know that probability of A given B is equal to probability A and B divided by probability B. So this time we have probability of x given y is equal to 2. So it's denoted by f of x given 2. So that'd be f of, so maybe let's write in the probability notation first. So that'd be probability of basically x is equal to x and y is equal to 2 divided by probability y is equal to 2. Okay, so this is the same as f of x comma 2 over, and this will be the marginal density of x given y is equal to 2. Okay, so y is equal to 2, or it's the marginal density of basically, so another notation that they have, it's h of 2. That's what we have for probability y is equal to 2. So it's in marginal density notation, it's the marginal density of y at y is equal to 2. So this is the same as f y at y is equal to 2. Okay, so fx2, now this is going to vary as x varies, but the h of 2 is always constant, so it would be, so f of x given 2 is equal to f of x2, and h of 2 we already know is 0.35. So as x changes now, when x is 0, so f of 0 given 2 would be f of 0, 2 divided by 0.35, And from the table, we see that f of 0, 2 is 0.06. That's 6/35. Then f of 1 given 2 would be f of 1, 2 over 0.35. And f of 1, 2 from the table is 0.07. So that is 7/35, which is 1/5. And then lastly, f of 2 given 2 means f of 2, 2 over 0.35. And f of 2, 2 from the picture, from the table is 0.22 over 0.35. So that's 22/35. 6/35, 1/5, and 22/35. 6/35, 1/5, and 22/35. Find expected value of x and variance of x. So let's open a new file. So e of x would be the summation of x times, and what are they calling it? G of x. Basically, it's a summation of x times a marginal distribution of x. So it would be 1, 0 g of 0 plus 1 g of 1 plus 2 g of 2. So this is 0 plus 1 g of 1 is 0.36 plus 2 times 0.41. So 0.82 plus 0.36 is 1.18. So that's E of x. And then variance of x. For variance of x, we use the same formula. It would be E of x squared minus EX whole squared. So we need to find E of x squared. E of x squared is the same as E of x. Now, if squared pieces zeros, you square the x values. So the same thing as here. Let's even write it down in the summation form. X squared gx equals 0 squared g0 plus 1 squared g1 plus 2 squared g2 equals 0 plus 0.36 plus 4 times 0.41. So that's 2 exactly. So therefore, variance of x be E of x squared, which is 2 minus EX whole square. So minus 1.18 whole square. And let's find it out. So 2 minus 1.18 squared. It's 0.6067. Oh, okay. Let me see. So E of x is this. Okay, round to, well, that's also correct. Round to 4 decimal places. 0.60. Okay, 0.6076 is what I have. 0.6076. Okay, and now we want expected value of x given y is equal to 2. So expected value of x given y is equal to 2. It would be the summation of x. So normally, if you just wanted expected value of x, it'd be summation of x times g of x. So in this time, x times the distribution of x. So this time it would be x times the distribution of x given y equals 2, which we were calling as f of x given 2. X given 2. Okay. So the x values are what we have, 0 and f of 0 given 2 plus 1, f of 1 given 2 plus 2, f of 2 given 2. So you just have to remember based on this table that 1 given 2 means x is 1 given y is 2. So this is just going to be 0. The f of 1 given 2 was 1/5 plus 2 times f of 2 given 2 was 22 by 35. So 44 plus 7 is 51 by 35. Now variance of y given 2. Okay, variance of x given y is equal to 2 would be the expected value of x squared given y is equal to 2 minus e of x given y is equal to 2. So we already have e of x given y is equal to 2. That's 51 by 35. So we need to calculate e of x squared given y is equal to 2. So it would be the same as the e of x thing, but now instead of x, we will have x squared. So it would be summation of x squared f of x given 2. So be 0 squared f of 0 given 2 plus 1 square f of 1 given 2 plus 2 square f of 2 given 2. So that's 0 plus 1/5 plus 4 times 22 by 35. 88 plus 7 is 95 by 35. So that's 19 by 7. Okay, and that's the e of x squared. Now we are ready to get the variance. The variance of x given y is equal to 2 would be the e of x squared, which was 19 over 7 minus ex whole square, and everything is given y equals 2. So this was 51 by 35 whole squared. Okay, so let's calculate 51 square is 2601 and 35 square is 1225. And now take the common denominator, which is 1225. 7, 1 times 7, 52, 7 times 49, and 5 times 35, minus 2601. Okay, let me check. 1225 by 7. 175. Okay, something is not right here because variance can never be negative. So let's check this one again. 88 by 35 plus 7 by 35. 95 by 35. 4 times f of 2 given 2. So this is 88 by 35 plus, okay. Okay, so all right, I divided the 1225 by 7, that's 175, but I have to time it with 19. So it's 175 times 19, and that's 3325. 3325. That's right now. 3325 minus 2601. That's 724 over 1225. Okay,